Hey, welcome back. This lesson is going to be an introduction to parametrized surfaces. Now, just like parametrized curves, parametrized surfaces are a way to describe surfaces that essentially let us do calculus on them. I think they're super cool and fun and interesting, but they are also challenging to understand at first. So what we're going to do in this lesson is just a brief introduction to what a parametrized surface is. And then in your next class and the subsequent video lesson, you'll get a lot more practice coming up with surface parameterizations and seeing how they work. All right, let's get into it. So I'm going to introduce the idea of a parametrized surface to you through an example. Here it is. So the question is, what curve in three-dimensional space is parametrized by this parametrization, which I'm calling R1 of t, and it is 3 cosine t, 3 sine t, and 5. So when I say what curve, I mean what path in R3 is traced out as t increases and we look at all of the points of this form. So looking at this, if we just ignore the z coordinate for a second, then x and y are cosine and sine, which we know will parameterize a circle. And since there are 3's in front, we know that we have a circle of radius 3 if we were just looking at it in x and y. And since z is just constant, it's just 5, we know that we're looking at the circle of radius 3 centered at the origin in the plane z equals 5. All right, let's draw that. Okay, so here we go. Here's this circle. We're calling this R1 of t. Okay, next question. What curve is parametrized by this formula? So R2 of t is 3 cosine t, comma 3 sine t, comma 2. Okay, there's not much different between these two things except for the z coordinate. Just like before, this is a circle of radius 3 in x and y, and now the z coordinate is 2. Okay, so before we had a circle in the plane z equals 5, and now we're going to have a circle of the same radius in the plane z equals 2. And okay, just one last question. What curve is parametrized by this? R3 of t is 3 cosine t, 3 sine t, negative 1. Okay, at this point you're probably wondering, what's the point of all this? All these questions are essentially the same question. You're right, I'm going to make a point in a second, but this curve is a circle of radius 3 in the plane z equals negative 1. So it looks like this. Okay, so 3 circles, all of the same radius, all centered at the origin in their corresponding planes. The only thing that's different about them is the plane in which they live. The last thing that I want to ask is, what is parametrized by this? And I'm going to call it R of t comma u. So this is a thing with 2 input variables. It's going to look like these in the sense that we'll have 3 cosine t, 3 sine t. But then for the z coordinate, I'm going to put u. So what is this? This is a function whose input is 2 variables, t and u, and its output is points in 3-dimensional space. And so going back to these first 3 things, the only thing that was changing was the z coordinate. And now for this new parameterization, if we're saying the z coordinate is u and u is allowed to vary over all possible real numbers, then what this is describing is, in a sense, every circle of radius 3 at every possible height along the z-axis. And maybe you can already see what shape that would make because we have 3 of the curves drawn here. But if we take every circle at every height along the z-axis and connect them all together, we get a surface. And the surface that we get is the cylinder of radius 3 centered around the z-axis. So I've tried to draw this pink cylinder here. This is R of t comma u. So it is the output of this function here for every t and u. And so this thing here, the function with 2 inputs and whose outputs were points in 3-dimensional space, this is what we call a parametrized surface. And another way to say it is that this formula is a parameterization of this cylinder of radius 3. Now, what you'll work on in class is coming up with your own parameterizations of different surfaces. And we're going to go over this a lot more in the next video lesson. But while you're working on this in class, that's a thing to think about, is like thinking about what happens when you fix one of the variables and look at the curve that you get parametrized by essentially the other variable. That will be something that you might find helpful while you're coming up with surface parametrizations. Okay, that's actually going to do it for this one. I've intentionally given you not a lot of guidance on how surface parametrizations should work, besides the definition, because I think it's something that you will benefit the most from by trying to come up with them yourself. So that's what you'll be doing in your next lesson, and then in the subsequent video lesson, we'll spend a lot more time studying parametrized surfaces, and we'll talk a little bit more about the strategies for coming up with them. So I hope you enjoy the upcoming class. Thanks for playing along, and I'll see you in the next lesson.